Today, we're going to cover how to set up default memory requests and limits for a namespace in Kubernetes. This is essential for optimizing resource usage, especially in production settings where you want to ensure stability without overloading your nodes. Imagine a real-life scenario. You're managing a Kubernetes cluster for an online retail platform with multiple microservices handling everything from inventory to user authentication. Some of these services are lightweight, while others are resource-intensive. If you leave memory limits unchecked, you may end up with memory-hungry pods competing with lightweight services, causing crashes or performance dips. That's why configuring memory requests and limits per namespace can be a game-changer. Before we dive into configuration, let's quickly understand what memory requests and limits are. In Kubernetes, requests define the minimum amount of memory a container is guaranteed, while limits set a maximum threshold. Requests ensure your app has the minimum memory it needs, while limits prevent any single pod from consuming too much memory on a node. Setting these values at the namespace level means that any new pod deployed in that namespace inherits these defaults. This is incredibly useful in environments where you have mixed workloads or need to standardize memory allocation without manually setting limits on every single deployment. Let's expand on our e-commerce platform example. You have several microservices, such as checkout service, inventory service, and user auth service, all deployed in a production namespace. Some services, like checkout service, need more memory than others to process real-time transactions. Others, like user auth service, might need less. If you don't have memory requests and limits, you might face issues during peak times. Suppose the inventory service tries to allocate more memory than available. It could crash or slow down other critical services like checkout service. By setting default memory requests and limits, you can prevent these scenarios by ensuring each service has enough memory while capping any memory-intensive ones. Now, let's configure memory requests and limits in Kubernetes. To set these at the namespace level, we'll use a LimitRange resource. Here's how it works. First, create a YAML file for the limit range. Let's call it memory_limitrange.yaml. In this file, specify the namespace you want to apply these defaults to. Then, define default requests and limits for both CPU and memory. Here's an example configuration. In this example, every new container in the production namespace will have a default memory request of 256 miles and a limit of 512 miles. So if a container doesn't specify memory values in its pod spec, Kubernetes will apply these default values automatically. Once you've defined your limit range configuration, you can apply it to your cluster. Run the following command. This will create a limit range in the specified namespace, in this case, production. From now on, any pod you deploy in this namespace without explicit memory settings will inherit these defaults. Let's verify that the default memory settings are applied. Deploy a simple pod without specifying memory requests or limits. Here's a quick example YAML for a basic pod named testpod. After deploying, describe the pod to see the applied memory settings. kubectl describe pod testpod and production. In the output, under the container section, you should see that the memory request is 256 miles and memory limit is 512 miles. Even though we didn't specify these values in the YAML file. This confirms that the defaults from the limit range are working as expected. Now, let's discuss why this configuration can be so helpful. By setting up these limits, you're essentially protecting your cluster. You ensure no single container can hog all resources, which is critical in a production environment. This prevents any unexpected memory spike from impacting the performance of other services. This configuration also helps teams working on different services to follow standardized resource allocations. So, even if new developers join, the defaults ensure they don't accidentally misconfigure resource limits. And that's how you configure default memory requests and limits in Kubernetes. Setting these up at the namespace level helps keep your cluster stable and simplifies resource management in environments with multiple services. If you're running a production-grade cluster with various teams deploying services, this is a must-have for operational efficiency. Thanks for watching. Make sure to like and subscribe for more Kubernetes tips and tutorials.